Hello everyone. Today I'll be presenting a talk on fighting money laundering with Julia. Uh, Agenda of the talk is we'll briefly see what is the forensic investigation process, then what's the double standard, and how it's related to open source, especially Julia and other languages. Then how we can perform bank account analysis or fund trail analysis, because that is the basis for our money laundering issues. Then finally, conclusion. So whenever we see any forensic investigation process, these are the steps involved: identification, collection, validation, examination, preservation, and presentation. So in the first step, the investigation officers, they are going to collect the bank statements of suspects from various banks, because the money transfers between several accounts, so they need to get the details of all these accounts. So once they do it, once they collect the statements, they need to make a copy of it. They need to convert that into unified format, because every bank has got a different statement format. They need to bring the data to unified format, and they need to save it. They need to make sure that whatever data they are bringing into unified format is not altered, is not tampered in between, because that is the important step here. The goal of forensic investigation process is to identify the evidence which can be submitted in the court of law. So if there is alteration, if there is any tampering, then court will not accept. So that's the very, very important step. So finally, it has to be submitted in the court of law. So let's see the double standard. So in United States federal law, the double standard is a rule of evidence regarding the admissibility of expert witness testimony. So there are some illustrative factors which the court has suggested. So has the technique been tested in actual field conditions, not in just the laboratory? Has the technique been subjected to the peer review and publication? What is known or potential rate of error? Do standards exist for the control of techniques operation, and has the technique been generally accepted? So in 2003, Brian Carrier published a paper. So there he examined the rules of evidence standards, including the Daubert, and concluded that the guidelines of the Daubert tests, what we have discussed earlier, so they conform to open source tools than the closed source tools. So here, with respect to programming, we need to consider these questions. Can the program or algorithm be explained? This explanation should be explained in words, not only in code. Has enough information been provided such that thorough tests can be developed to the test of the program? Then have the error rates been calculated and validated independently? Has the program been studied and peer reviewed? And has the program been generally accepted by the community? So Julia satisfies all these conditions. So we can consider Julia as one of the languages for analysis of forensic information. So this is one of the pressing problems. So in India, in most of the recent hackathons, we are seeing this problem being given by investigative agencies. So examples of money laundering. So I'll skip this. So one of the important parameters which we need to consider is the politically exposed persons. So these are the persons who are having eminent positions in the government, maybe who are part of assembly and so on, who are ministers of the government and their close relatives. So there is a financial action task force which has been formed in 1989 and is based in Paris, which is basically trying to address the issue of money laundering, and many countries are part of it. So this is the money laundering scenario. What happens is there are three stages basically. One is placement, layering, and integration. So in placement stage, sender splits the money into several small chunks and deposits in large amounts of bank accounts, and finally the integration happens and the money is received by the receiver. So the solution is that first get the statements from different accounts, then identify, bring it to the unified format, then you can apply Benford's law on these statements. So it gives you some idea regarding whether there is a possible fraud or no. Then generate a graph showing the different links between the accounts, then try to predict the possible money laundering. And in all these things, you have to record each and every step. That is very, very important, because reproducibility is very, very important, because your opposition lawyer may question the things, and at that time you may have to repeat the steps and show that you are getting the results. So this is a Benford's law. So Benford's law is a first digit law, leading digit law. So there's a distribution. So the number of ones are 30%, number of twos are between 15 and 20%, and so on. So your statement should follow this. It should follow the Benford's distribution. So if it follows the Benford's distribution, then you can say that there is no possible money laundering. If it doesn't follow the Benford's distribution, then there is possible money laundering. So I have written a code here, so you can see here. Okay, yeah, see this output. So for the first case, it is not adhering to the Benford's standard. So now consider this graph. This is following the Benford's standard. So that means there is no money laundering case here. But this is how we can link. Important part, we also need logging packages. Yeah. So finally, conclusion. So frontal analysis is very complex, and whatever I have shown, it's a very simple thing. So more advanced techniques and tools are required. Thank you.
All right. I think we've run out of some. Okay, we have one question.
Don't the money launderers also know about Benford's law?
So the question was, don't the money launderers also know about Benford's law? I think...
yeah, natural numbers follow the Benford's law, but that's the manipulation. So it can be detected. And it is just one indicative tool. So it has to be used along with advanced machine learning tools.
All right. Let's also thank the speaker once more.